Today we will going to conduct a load test on single cylinder 4-stroke diesel engine. Okay, so in this load test we will going to apply different loads at constant speed and find out the fuel consumption at different loads. We can take a fuel consumption from this fuel tube. With the help of gravimetric analysis, we can take a 10 cc fuel consumption for an individual loads. Also, we will going to note time taken for 10 cc fuel consumption, right? So, before starting this experiment, we need to calculate a maximum load for this engine. So, the engine specifications are given in the name board. So this is a vertical engine, 4-stroke, water-cooled, diesel as a fuel is used. The speed of the engine is maximum speed is 660 rpm. We will going to maintain the 660 rpm for different loads. And then the power of the engine is 6 horsepower. Here we have a loading arrangement as rope brake dynamometer. We have different type of loading, hydraulic loading, eddy current loading, electrical loading, all those things. Then this specification of the engine is the bore of the cylinder is 114.3 mm and stroke length. The orifice meter is given for the volume consumption, air consumption. Then we can start this experiment with the help of first calculating the maximum load. So the maximum load can be calculated from this formula, from the brake power formula. We can calculate maximum load 2 pi n REW by 60 into 1000. So this RE is called effective radius. This can be measured from the brake dynamometer. This is a brake dynamometer. So this is a brake drum which is attached with the engine. So we need to measure this drum's circumference and then we can measure this rope circumference. After measuring this rope circumference and drum circumference, we can calculate the effective radius. After inputting this effective radius here, we know the brake power of the engine is 6 HP. We need to calculate this HP into kilowatt. So 1 HP is equal to 745 watts, which is 0.745 kilowatt. So 6 into 0.745 is equal to 2 pi, in the speed of the engine is 660 rpm. We need to calculate W. So W is equal to the maximum load which is applied on the engine is 28 kg. So this 28 kg can be applied on the splitted manner. First we will take a 10 cc fuel consumption for no load condition. After that we will going to apply 7 kg, then 14 kg, then 21 kg, then 28 kg. Okay, so this is how we have to apply the load on the engine for calculating the different performance of the engine. Okay, so we will see the construction of an engine. So this is a 4-stroke single cylinder diesel engine, right? Because it has only single cylinder. This is an intake manifold. Here you can see this is an intake manifold which is attached with an air drum. Okay, so this air drum is used to find out how much amount of mass the air is going to the engine. This is directly connected with this U-tube manometer for find outing the volume flow rate. Then the fuel tank of the engine is connected to this fuel measuring tube. So the fuel is first coming to this fuel measurement tube and then it going to the engine, right? So then this is an exhaust manifold. The exhaust air gas will be going to the out of the lab. Then this is a cylinder head. Okay, so this is a cylinder which is called the cylinder head. In the cylinder head, the intake and exhaust valves are arranged. This is intake valve and this is an exhaust valve. Intake valve and exhaust valve, which is operated by a cam which is fitted in the crankshaft. here in the downside, in the crankcase, the crank and crankshafts are attached. Okay, so the valve is operated from this. This is push rod. This is intake and exhaust valves. Push rod. This is a decompression lever. Okay. This is a decompression lever. Before starting the engine, we need to lock the exhaust valve. Then we can start by rotating the crankshaft. We can start the engine. Then the fuel is directly coming to the fuel filter. After that, it goes to the fuel pump. Then it going to the fuel injector. In the diesel engine, we are using injector to inject the fuel. Okay, so here the injector is there. Then the process of combustion will start. Okay, the 4-stroke engine have suction, compression, power and exhaust stroke. Okay, so these two large wheels are flywheels of an engine. This is a low speed engine. So the engine can be started using the key provided here. So now the engine will be started. How the engine is started is shown here. First you need to remove this fuel cut-off valve. After fixing this decompression lever, we need to rotate this, and then now the engine is starting. Okay. So